Hello, this is 7.4, showing triangles are similar by side, 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 and side angle side. So the last section we talked about was showing triangles are similar using angle, angle. So if you can show two angles are congruent and corresponding, then the two triangles have to be similar. Well, we can do the same thing with all three sides, or two sides and an angle in between them. So if we have two triangles, if we want to show that these are similar, we can show that A and D are proportionate along with B and E. Or C and F. If you can show all three of these fractions are the same ratio or fraction, then we know that the triangles have to be similar. Another thing is to show two sides are proportionate and the angle in between them is congruent. Then you know the two sides are proportionate and the angle in between is congruent. You know that the two triangles are similar. That's what we're doing. Side, side, side. So here's where they talk about the three different ratios of sides. So AB compared to FG. So AB compared to FG, GH to BC, FH to AC. If you can show that those are all the same ratio or fraction, then you know that the two triangles are congruent. Okay, so here we look at, it says here, B to triangle A. So we're going to take triangle B ratio, so 4 compared to 8. Is that the same as 6 compared to 12? Is that the same as 5 compared to 10? If I were to actually use decimals to help me with this, they are all 0.5. So they are similar. The scale factor is every one of these simplified, which is 1/2. So that is my scale factor. Let's see, write a similarity statement. The similarity statement, remember, is to take corresponding points. So let's say we have STU is similar to triangle. S corresponds to P, T corresponds to Q, and R corresponds to U, so it would have to be in that order. Is either triangle DEF or GHJ similar to ABC? Okay, again, we need to just set up the proportions. So let's try these two first. So let's take green to green. They already set that up for us. 8 to 12 and 4 to 6. Are these the same? Well, this is 2/3. This is 4 goes into both 2/3. 2 goes into both 2/3. So yes, these two are similar. Let's try the other one. So we have 14 to 12, 6 to 6. Well, that right there is not the same. 10 to 9 is the other one. So this is no. All right, go ahead and try these. This 1 and 2 here, determine whether the triangles are similar. If they are, write a similarity statement. Go ahead and pause the video, try it, and see how you do. I will go over those in just a second here after you are done. Okay, welcome back. Let's identify which sides would be proportionate if they had to be or could be. We always want to look at the lowest sides. So 12 and 8 correspond because they are the lowest sides or the side lengths of each triangle. So they would have to correspond. So 8 to 12. The next one has to be 15 and 10. Oh, 10 goes first and 15. And then 12 to 18. Are these the same ratios? Again, if you want to make them into decimals and see if they're the same ratios, do that. I know this is 0.67. This is also 0.67. This is also 0.67. So yes, they are similar. So triangle ABC is similar to triangle, and it would have to be DFE. There's my similarity statement. Okay, let's try this one. 5 compared to 9. Is that the same as 12 compared to 12? And of course it's not. So these are not similar. Side angle side. Again, you got to have proportionate sides, but then the angle in between has to be congruent. This one, first of all, right away, the angles are congruent, so that helps. Is 3 compared to 5 as 6 is compared to 10. We could use cross products. 3 times 10, is that equal to 5 times 6? 30 is 30, so yes. Write a similarity statement again. ABC, let's try that. Is that similar to triangle? Then it would be DEF. Show that this is similar. Okay, so we're looking at 2 triangles. We got VYZ and we have VWX. We know V is congruent to V. So we know that angle is congruent. We need to prove that then this side, which is 4, compares to not 8, but 12, because it's both of these added together. This side is 15, and this side was 5. So 4 compares to 12 as 5 compares to 15. 60 equals 60 using cross products, so it is correct. All right, again, let's try this one. You go ahead and pause the video, try it, and I will go over it here in a second. Okay, welcome back. We will start with this one. 6, does that compare to 8 as 8 compares to 12? 6 times 12, is that 8 times 8? And that is not correct because this side's 72 and this side's 64. So it is not similar. This one, we've got 3 compares to 6 because you got 3 here compares to 6 as 5 compares to 10. That is correct because that is 0.5 and 0.5. Plus this angle is the same on both. So your similarity statement is triangle PQR is similar to triangle PST. And that's it for section 7.4. Good luck with that one. Let me know if you need help.